Okay, so we're going to talk about standing waves here. All right. And a standing wave is a wave that appears to be motionless, um, but just oscillates back and forth. And that's due to an interference pattern. So there's the definition. Um, and here's what we're talking about. So we just talked about the previous two topics. We talked about what happens at a boundary with reflection and things like that. And then also we discussed superposition or interference. Okay. Now, what we know is if I send a pulse, whoops, sorry, we want to undo all that. If I send a pulse down a wave to a fixed boundary, here, what we know will happen is it will get reflected back with the opposite amplitude. So as this goes this way, it'll bounce back and it'll bounce back down here like we've shown before. But what happens if I don't just send a single pulse? What if I send a whole wave down towards a fixed boundary? So what you're going to see here is when this first trough gets to the boundary, sorry, my pen's not wanting to work. When that trough gets to the boundary, it's going to reflect back, but it's going to reflect back with the other amplitude, which will then interfere with this crest. For some reason, my pen doesn't want to work. All right, which will then travel through and then hit and reflect back, which will then interfere with this trough, and so forth and so on. And so what you end up seeing is that the waves that is being transmitted in the first direction starts interfering with itself as it gets reflected back. Now, because this is happening, what ends up happening is this really cool pattern emerges, and it's called a standing wave. Okay? And so what ends up happening is this. So I'm going to clear this off and try to redraw this. All right? So what ends up happening is you get this pattern, and for some reason my pen is absolutely not working right now, and I don't know why. Let's try this. So what you get is, well, for crying out loud, is this pattern like this, but on the way back, all right, well, excuse me, you get this, and then, but also at the same time, the wave also will follow this pattern, follows this type, and it creates this shape, okay? And so what ends up happening is the wave appears as though it quits moving forward, and it just looks like it stays in place. In other words, you get these points here. Let's see if I can use it. I'm going to use a different color for this. Here, 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 and here that never get above a zero amplitude. They always stay as a point of non-disturbance. So these points of non-disturbance don't move laterally. They stay in the same place. Then you have these other points here and here, all right, where the amplitude can be a maximum. And those crests and troughs, while they oscillate back and forth, they stay in the same place. And this is because of the interference pattern, because the wave that's being sent down towards the anchor reflects back and starts interfering with itself. And this pattern emerges where the points of non-displacement are always the same. And the other points are always the same as well. So they have names. This one right here, and there we go, is called, these are called nodes. Okay. And sorry, I'm having to write with my finger because my computer's not picking up my pen. So I'm using my finger instead. So that's why this is going to get a little messy. All right. So that is called a node. So this is a point here and here and here. These are the points of non-disturbance. Okay. So a node is where there is destructive interference, and this position doesn't change because if you keep the frequency the same, that destructive interference will happen at the same place because the wave is moving the same speed as we've covered before. And so those nodes, they never have an amplitude once the standing wave has been created. However, these points here, these would be called an antinode. All right. And so these are positions of antinodes. And this is a position of our maximum interference, or excuse me, maximum amplitude. So what happens here is when the waves collide, there's a possibility that they can have an amplitude, and that'll be the maximum amplitude. So to refresh, the nodes are where there is destructive interference, and then the antinode is where the amplitude can be maximized. All right. Now, I'm sorry for the poor drawing here. Like I said, my pen has quit working, and I haven't been. I'm had to draw it all with my finger, so I'm sorry. Now, that being said, you should be able to grab a slinky now, and then have one person stand on each end of the table, have one person be an anchor, the other person just continuously send a wave down. You'll notice initially it appears once the waves are going, they'll start hitting the other end, and then they start getting reflected back. And once you see them start to get reflected back, you'll see the standing wave pattern form, and then the antinodes and nodes will become very clear. You can change the number of nodes and antinodes by changing the frequency that you oscillate or send waves down. So if you do long wavelengths